All right, chapter 8, we're going to talk about conic sections and parabolas. So you'll need to know what a conic section is. And so here you've got a right circular cone, and it's got two naps. That's each part of this upper nap and lower nap. And how this is constructed is this way. If you've got two intersecting lines, and you make one of those lines an axis, see this axis going right through the middle? And if we take the other intersecting line and we rotate it around that axis, it's going to form a cone. Okay? The one that goes around is called the generator. You can see that there. What's going to happen is, if the lines intersect, then when you rotate it around, it's going to make two cones. It's going to make this upper nap and this lower nap. Conic sections and degenerate conic sections. So what you're looking at is that same cone that was formed from the previous slide, and what we're doing now is we're taking splices of that. Okay? So if you take a splice through the side like this first one, it's going to form an ellipse. If you take one that's going to be going through the top here, you can see that that forms a parabola. This one you can't see because I got stuff in the way. And if you take a conic section that's going through both of the naps, you see it going through both the naps on the end, that's going to be a hyperbola. Okay? It looks like a parabola up and a parabola down. It's called a hyperbola. Right? So those are the different things we're going to be looking at today. Here's the rest of them. So if you take a plane and you cut it right through the middle of the two naps, that's just going to be a point, because there's one point at the intersection where they both meet. Okay, it's right at the vertex. If you take, it says right here, the single line plane tangent to the cone. So what's happening is it's going right next to the outer edge of the cone and then right through the vertex. You can see that in the picture. And then, of course, the last one I got covered up again. Intersecting lines. If I take it and I go straight through the vertex, then we're going to have intersecting lines. You see what's happening? You see the red lines? There's one coming from one side of the cone going through the vertex, one going from the other side through the vertex, and so they're intersecting lines. You see it? Okay. Whereas the one in the middle is just a single line because we're just riding the edge of the cone. Everybody good with that? So if you had a cone and you just put something flat up against it, that would be that middle one. All right, good. Second degree quadratic equations in two variables. There's the form. So the conic sections can be defined algebraically as the graphs of second degree quadratic equations. What's going to happen is you're either going to have what you would normally look at as a parabola, a y equals something x squared kind of a deal, or it could go the other way where you're going to get an x equals something y squared. Now, what's the difference? If you've got y equals x squared, the graph, the parabola is either going to open which direction or which direction? Up or down. Okay? And we tell whether it opens up or down by the number, the coefficient in front of x squared. If it's negative, it opens down. If it's positive, it opens up. Now, the thing that we're going to have to get used to, and we've seen it before when we were doing inverse functions, is you can also have a function that's got x equals something y squared. And so those open which direction? Left and right. And so if the coefficient in front of y squared is positive, it's going to open to the right. And if it's negative, it's going to open to the left. Okay? So we're going to be able to pick those out as we're looking at some of these problems and figuring them out. But that's why the equations down here have ax squared plus bxy plus cy squared plus dx plus ey plus f. And it says a, b, and c are not all 0. Okay? Which means you could have an x squared and no y squared, or a y squared and no x squared. Here's the parabola that we're going to be focusing on for this section. And you guys know what a parabola is. But it tells us here that it's a set of all points in a plane equidistant from a particular line, which we call the directrix. And so you're going to have to know how to find that directrix. Okay? And for us, it's either going to be a horizontal line if the parabola opens up or down, or it's going to be a vertical line if the parabola opens left and right. And that line is always to the outside of the parabola. You can see it's to the outside of the parabola, it's not inside, right? So it's going to be equidistant from a particular line, the directrix, and a particular point, which we call the focus, and the focus is going to be on the inside. I'm going to show you how to find those in a second. And so what's happening, if you look at the picture, from the vertex to the directrix, and from the vertex to the focus would be the same distance. And the focus, like I said, is always on the inside of the parabola. Okay, graph of x squared equals 4py. So you can see that we've got x squared, so it's either going to open up or it's going to open down. Okay? Now, p, we're going to use p to find our focus and our directrix. So pretty much whatever number is in front of, in this case, y, we're just going to divide that number by 4, and whatever we're left with is going to be our focus. Okay? Now look at the directrix down here and how this all sets up in the picture. Okay? Our focus is going to be 0p because our vertex hasn't moved from 0, 0. And since we have a parabola that's opening up or down, all we're going to be doing is going from 0, 0, and we're going to be going up if the parabola opens up to find the focus, or we're going to be going down if the parabola is opening down to find the focus. Okay? And so what's going to happen is our x-coordinate does not change from 0. Now what would make that change is if we actually did some translating of the vertex, which we're not looking at right now, so don't worry about that. And so what we would do is we would take whatever number's in front of y, divide it by 4, and that gives us p, and so that's going to be our focus. Well, according to the last slide, if the directrix is the same distance from the vertex as the focus, then doesn't it make sense if our focus is at 0p that the directrix would be at negative p? Because that would be the same distance in the opposite direction from the vertex. Why can't I say vertex today? And so that's how we get this y equals negative p down here at the bottom. So for example, if our focus was 0, 4, then our directrix would be y equals negative 4. Or on the right-hand side, let's say the focus is 0, negative 4, then the directrix would be at y equals 4. It's the same distance away from the vertex as the focus. And so typically we find the focus first, and that helps us find the directrix. But you're going to get some problems for homework where they're going to give you the directrix and ask you for the function, and so we can use that to find the focus. We can do all kinds of stuff with that. And you're going to see what all that means and why we need it here coming up. Some people like this because they like looking at things and it makes it easier on them. So if you want to write these down, this is the parabolas with the vertex at 0, 0, which means that your graph in standard equation form is going to look like one of these two at the top. They're not adding or doing anything to translate the vertex, so it's just 0, 0. So we know if we have something y equals x squared, it opens either up or down. I already told you that the focus then would move up or down. It would still stay at 0 for the x. So it's going to be 0p. Directrix is y equals negative p, just like the last one. And the axis is going to be, the y-axis is going to be the axis of symmetry in this case. Your focal length, it says your focal length is p. It's going to be the distance from the vertex to the focus is your focal length. Don't confuse that with the focal width. The focal width is always going to be the number that's in front of y or x, okay? Because that's going to give you the distance, and it's always positive because it's the length, okay? The only thing that changed on the other side is now, when you have the y squared, it's going to either open to the right or to the left, and so now when we're doing the focus, instead of moving it up or down from the vertex, we'd be moving it left or right, because it's opening left and right. So we keep y at 0, and now we move our x-coordinate to move it left or right. So the focus would be p0 instead of 0p. And also the directrix will be a vertical line instead of a horizontal line, because a horizontal line would cut through the parabola. So it would be a vertical line at x equals negative p, and then the x-axis would be what our axis of symmetry is. Focal length and focal width would still be the same thing. All right, here's the graphs going the other direction, so you can see them both directions. So if you've got a y squared, we know it's going to open left or right. And in case you forgot why it opens left or right, remember that if you were going to solve for y and type this in your calculator, when you do the square root, it's plus or minus. So the positive would be the top, and the negative would be the bottom side. And anyway, so you can see that the focus now moves left and right. The directrix is now a vertical line. And still to find p, you would divide whatever's in front of x now by 4, and that would give you what your focus is. And your directrix, you just have to go the opposite direction. Okay. Now, this is only the case when your vertex is at 0, 0. We have to make some adjustments if we move the vertex. They're not difficult adjustments, but remember that all these are standard form with the vertex at 0, 0. All right, this wants us to find an equation in standard form for the parabola whose directrix is the line, x equals 3, and whose focus is the point negative 3, 0. So, first thing you need to do is determine whether or not this parabola is opening left and right or up and down. And you can tell that based on the directrix line. So if the directrix line is x equals 3, what kind of line is that? Vertical or horizontal?
Left, right.
X equals 3 is vertical, right? 3, 0, 3, 1, 3, 2, 3, 3. It's vertical. So if it's a vertical line, then which way is the parabola opening up? It can't open up and down because then the line would be cutting it. It's got to be left and right. Okay? So we know that this is going to be one of those graphs that's going to be y squared equals something x. Okay? They're telling us that the focus is negative 3, 0, which means that they moved. That means which way is this opening up? The focus is negative 3, 0. It's opening up to the left because you moved it. Remember, the focus has to be inside the parabola. So now we've got a bunch of different information. We also know that the vertex has to be at 0, 0. Why do we know that the vertex has to be at 0, 0? If the directrix is at x equals 3 and the focus is at negative 3, the vertex has to be right in between those 2 points. Right? And they already told us that the y coordinate is 0, so that means it's at 0, 0. So, does anybody know what the graph would look like? Remember, we already know it looks like this, right? Y squared equals 4px. Everybody agree? Yeah. It's opening to the left, which means that the number in front of x has to be negative. We already know what p is. What is it? Negative 3. What's 4 times negative 3? Right? Let's look and see. See, it's not that difficult. Especially now, I'm going to tell you to do this, especially if you sketch the information on graph paper. If you sketch it, then you're going to see how it opens and where everything moves, and for visual learners, it's going to be a lot better. So you're going to want to be able to, you don't need graph paper, but you're going to want to sketch it. Okay? That's the first example. Here's now the parabolas with the vertex HK. Remember, if it's grouped, it's horizontal and opposite. That's what's happening here. Okay? So the only difference now is we've got something grouped with x, we've got something grouped with y, so now we're moving the vertex around to be HK. Okay? Now, it looks complicated, but once you find the vertex, the focus, you're going to move, so if it's an x squared, you're going to be moving the focus up and down, right? So you find the focus still by dividing whatever's in front by 4, and then what you're going to do is you're just going to move that and combine it with whatever the vertical translation was. So let's say if the vertex is at 1, 2, and the focus is 3, it's going to be 1, 5 if it's opening up. And then we would subtract that same number from the vertex's y coordinate to find the directrix. So this makes it look complicated, but really, once you find where that vertex is, and you find the focus, you're just moving it that much from the vertex. That's why I think graphing it is going to make it a lot easier. And on the other side, you notice that it's the same thing, but instead of moving it up and down, we're moving left and right when the parabola opens to the left or right. All right, so look here. It says find the standard form of the equation for the parabola with the vertex 1, 2, and the focus at 1, negative 2. So look, I still think if you sketch this, okay, if I sketch this and I know that the vertex is at 1, 2, it's right here. That's the vertex. And the focus is at 1, negative 2, which is right here. That tells me a lot. it tells me what direction this thing opens up. Doesn't it? Where does the focus always have to be on the parabola? It's got to be inside, right? Inside the parabola. So I'm sketching. This is not going to be correct, but I'm sketching. I know that my parabola has to look something like this. Everybody agree? Also, how far away from the vertex was this focus? 2 down and then 2 more down, so 4, right? All right, so that means I have to go 1, 2, 3, 4 above the vertex to get my directrix. Okay? So, this line up here, the directrix, is it going to be x equals or y equals if it's horizontal? Y equals, because y is staying the same. It's going to be y equals what? 1, 2, 3, 4, 5, 6. Everybody agree with that? Okay, now, it says find the standard form of the equation for the parabola, and you guys told me that from the vertex to the focus was a distance of 4, right? So that means P is going to be 4, right? Negative 4, actually, because we went down. So we should be able to use that to figure out what this equation is going to be. And so if you know that it's going to be, all right, let's do this first. Is it going to be x squared or y squared if it's opening up and down? X squared. Remember, y equals x squared is up and down, regular. All right, let's do this. What is going to be grouped with x because we moved the vertex to 1? Minus 1. Everybody agree with that? That means we move the vertex 1 to the right. Okay, it's going to equal 4p y what? It's grouped, so this is a little bit different because it's actually going to be grouped. So minus 2, right? And so we already know what p is. We went down 4, so it's negative 4, right? Okay, everybody agree with that? Yes?
Wait, did we get the 1 from the focus or from the vertex? Yeah. And the x minus 1, where does that come from?
It's from the vertex. Remember, we're moving the vertex.
The other one comes from the focus?
No, this one? From the vertex.
Then why is it minus 2?
Because it's grouped. So even though it's y, it's grouped. So what's happening here, let's just look at this. Is that what we got?
Sure.
X minus y squared equals negative 16y minus 2? All right, so let me,
It's 4 times 4.
okay, it's 4p, and p we went down 1, 2, 3, 4, we went down, so it's negative 4.
So p is the distance from the top dot.
To wherever the focus dot is, yes. So negative 4 times 4 is negative 16, and that's how we got that. So as you get more comfortable with seeing the same things over and over again, it's not going to be very difficult, but it's a whole lot easier when you sketch a graph. Okay? And we end up with the same thing. Negative 16, or x minus 1 quantity squared equals negative 16y minus 2. And we found our focus was 4. It says p equals 4, but we did negative because we went down. Okay? They got it negative 2, negative 16. But they should have put p as negative 4, so that's not right. Okay, now let's look at some problems together. They want us to find a bunch of stuff. So I think you can do this pretty easily. What's the vertex if there's no translations?
0, 0.
0, 0. Everybody understand that? There's nothing grouped with x, nothing grouped with y, so we didn't translate anywhere. So it's 0, 0. The focus, why did I put the focus? Wow. The focus is going to be whatever's in front of what. First of all, is this opening up and down or left and right?
Up and down.
Up and down because it's x squared. Okay? If it's opening up and down, that means we're only changing from the vertex the part that goes up and down, which is y. Right? So this is still 0. How do I find what the focus is? It's 10. Whoever said 10 over here? Who said that? Yeah, you take the number that's in front of y in this case and you divide by 4. Remember, it looks like this. X squared equals 4py, and p is our focus, so we just divide 40 by 4, we get 10. So this is 10. Okay? It's opening up. It's a positive 40, so our focus has to go up. All right, now, the directrix, we just go the opposite direction. So it's opening up and down, And here's the easy one. If you change y for the focus, then this is going to be y equals for the directrix. If you change x for the focus, it's going to be x equals for the directrix. This is going to be y equals what? If we went up 10 from the vertex, now we have to go down 10, which would give us negative 10. That's it. All right, here it says a certain parabola has the equation y minus 3 squared equals negative 16x plus 5, and they want us to find the vertex. So the vertex is negative 5 and 3. Okay? You translated x 5 to the left, and you translated y 3 up. Remember, it's groups, so we do the opposite. That's the vertex. Everybody good? Okay, the next thing we have to do is find the focus. So, first of all, is this opening up or down, or left or right? Left and right, because it's y squared, right? So which one from the vertex are we moving? Are we moving the x, because that's the one that goes left and right. Everybody understand that? All right, now look. The number in front of x plus 5 is negative 16. And again, remember, it's like this. 4p. What does p have to be?
Negative 4.
It's got to be negative 4. That's how far we're moving it from the vertex. Does this graph open to the left or to the right? Left, because it's negative 16. No. Yeah, sorry. Is it left? It's left. Everybody got it? It's going to the left, sorry. Everybody good? Okay? It's going to the left. So we need to move from the vertex, we need to move that x coordinate 4 to the left. So if it's at negative 5 and we go 4 to the left, it's going to be where? 4 to the left from negative 5? Negative 9. Everybody understand that? Negative 9. Everybody see what's happening? We move it 4 to the left because that's going to put it in. We know that it opens to the left because of the negative 16 in front of x plus 5. Okay, if it's positive 16, it opens to the right. So if that's going to be the focus, then it says, what's the directrix? And so if we went, so we changed x or y? X. So this is going to be x equals, and if we went 4 to the left, then now we have to go to find the directrix, we have to go 4 to the right. And so this one is going to be negative 1. Okay, now, focal width is really easy. It's the distance from the directrix to the focus. It's always just the absolute value of the number in front of, in this case, the x term. So it's just going to be what? Yeah. But the thing is, you don't want to get confused between focal width and focal length. Focal length is the length from the vertex to the focus. Focal width is the whole thing from the directrix to the focus, okay? So the focal width, in this case, is going to be 16. It's just a number. It's a length, okay? Okay, this one's not too difficult. It says graph the parabola. First thing all you have to do is look at it to see which way it's supposed to open. Up and down. X squared opens up and down. And so we know already then that it's not going to be C or D. Okay? And we also know that the vertex is 0, 0, because we didn't translate anything. And so this will make it pretty easy for you too, I guess. If you were going to solve this for y, it would look like x squared over 16, right? So, I mean, if I plug in 4 for x, wouldn't it be 4, 1? Everybody agree with that? It would be 4, 1, right? 4 squared is 16, 16 divided by 16 is 1. Well, out of A and B, what's the only one that works with that? Which one? A, right? These go by 2, so 2, 4, and then 1, and negative 4 would also be 1. So it's got to be A. So if you want to do it that way, you can. The main thing is recognize whether it opens up or down, left and right. And you should know that because we did a whole chapter on quadratic equations, y equals x squared stuff, right? So if you ever get x squared, you know it's going to be opening up and down. Y squared is going to be its inverse, so it opens left and right. Find the vertex, focus, and directrix, and then we get to draw it. So let's start with the vertex. What's the vertex? Okay, 0, 0. What is, and so is this opening left and right or up and down?
Left and right.
Left and right, so we're going to change the x coordinate, not the y, because it's going left and right. What is the focus on this one? Over 4. Yeah, it's negative 15 over 4. So whatever the number is in front over 4. So the focus is going to be negative 15 fourths, which means then that the directrix is going to be, oops, we changed the x, right? So it's going to be x equals, if we went negative 15 fourths, then the other one's going to be 15 fourths, positive. That's the directrix. And then it says draw the graph. All right, well, we know that that's going to be there, right? And I'm going to be honest with you how most people are going to want to do this. Most people are going to take that equation at the top and divide by negative 15 and just solve it like this. And then what they're going to do is they're going to, I mean, most people do it this way. You don't have to, but a lot of people are more comfortable with this. They're going to plug in numbers for y and then figure out what it's going to be. So like they may plug in, I don't know, 5, let's say, and that'll be 25 over 15, so it's going to be some negative something or other. But there's no real good, fun thing to plug in here. If I plug in 5 for y, that's 25 over negative 15. It's what, negative 5/3, right? Negative 5/3, which would be somewhere, what did I plug in again? I'm sorry. 5? And so what did I say, negative 5/3? Be right about there. Which means if I plug in 1, 2, 3, 4, 5 this way, it's going to be about right there. And that's how they're going to get their graph. You know it's going to be the same thing where you just click on the vertex and then you find another point on the graph. That's what's going to happen here. So your graph is going to look like this, whatever that may be. Okay? And looking at the problem, we already should know that it's going to, oh wait, that's not right. That's not right at all. I did the wrong thing here.
You did it right.
No, because I plugged the numbers in the wrong side. If this is 5, then over here would be, this would be the, what did I say it was, 5/3? Yeah, I went the wrong way. Which I should have known because we already said that the graph opens how? Yeah, it opens to the left. So negative 5/3 is going to be about 1 2/3, right? Negative 1 2/3. And that's going to be at 1, 2, 3, 4, 5. It's going to be here. 1, 2, 3, 4, 5, and it's going to be here. That makes way more sense. Okay? And that's the graph. Don't do what I did. If you already know which way it opens, you should be in good shape. Which is how we caught ourselves, I guess. So, okay? Good? Write an equation for the parabola with the vertex at the origin and the focus at 0, 0. So the vertex is at what? 0, 0. And then the focus, they tell us, is at 3, 0, which tells us which way this graph is opening. Left and right. It's actually opening to the right. Does everybody see why? If you sketch it, you will. Okay, if this is here, the vertex, and then we've got 1, 2, 3, and this is the focus, and we know the focus has to be inside the parabola, then we know if we were to sketch this, it's going to look like this. I don't know why I'm dash lining it, because it's a sketch. Okay? Now, because we know this from the sketch, we also then know that the equation is going to look like this. Y squared equals 4px. Does everybody agree with that? It's got to be y squared because it's opening to the right. Yes? Do we already know what p is? It's 3. So it's just going to be 4 times 3x. And so this is your equation. This is all there is to it. It's really nice when they don't translate the vertex. Okay? So that's going to be our equation for this problem. Okay, they give us information again. They give us a vertex. Is at 0, 0. I don't know why I just made it blue, but that's okay. So here's your vertex. And your directrix is at x equals -2. Is that a horizontal line or vertical line?
Horizontal.
Vertical. It's a vertical line. Here's your directrix right here. Okay? So if that's your directrix and it's 2 to the left, then where's your focus going to be? 2 to the right. It's going to be right here, which means that this graph is going to open what direction? To the right. My sketch again. And that helps me because I know what the form of this equation is. The form of this equation is it x squared or y squared? Y squared equals 4px again. And we know what p is. What's p? What's p? 2. This point right here is 2, 0, right? So it's 2. And so our equation is y squared equals 8. Okay, find the equation of the parabola with the focus at 0, 5. And our directrix at y equals 3. And they've already sketched it for you. So if this blue line is your directrix and that dot is your focus, you can find the vertex has got to be right in between it. So we'll figure that out.